I'm just going to talk about today how to calculate air quality index. Particularly, different countries are reporting on regular basis the air quality index. And if I ask you guys, what was actually, I mean, because first of all, I would like to thank Dr. Mohsina Zubair for setting stage and making my job a bit easier to why air quality index is very important. So if I ask you guys, what are actually the reason that the air quality index was developed, and because it's the major role or major things which are actually to tell us about the hazardousness of all these pollutants are actually the NEQs, National Environmental Quality Standards, which are actually we have a good elaborative presentation from Dr. Mohsina. So why we need it? So any volunteer for this? A quick response. Yes, we have a response from Muhammad Hassan Bajana. He said to assess the health of people is protected, sort of benchmark. I would say it's true. It's a sort of benchmark, but it's not to assess the health of people is protected or not. It is just to educate the people that air quality is good enough to go outside and do your to be very to your outdoor activities and some similar kind of activities to do your daily routine life. It's just to educate people that whether the air quality or air pollution level, which are measured for different criteria pollutants, which are mainly 5 or 6. And so for just layman, because you have seen that air pollutants are actually measured in micrograms per cubic meter. And for layman, it's very difficult to gauge whether how many micrograms per cubic meter should be good for me or not, for good for will be moderate or would be unhealthy or something like this. So in order to simplify this procedure and educate the general public or the masses, the air quality indices were used, and of course they are based on these air quality criteria pollutants, which I have actually elaborated in my previous lecture from yesterday. So air quality index is has been developed by the environmental protection agencies to provide accurate information about daily levels of air pollution and its health effect. It's a simple color coded. For instance, here it looks like this. So I mean 6 colors with certain numbers starting from 0 to going up to 500, and the color coding has certain meaning as well, which we will explain later on. So unitless index, that is an effective way to communicate air pollution concentrations to the general public. It focuses on health effects you may experience within a few hours or days after breathing unhealthy. So it depends. So all these, as I mentioned yesterday, all these standards are actually established on the basis on their impact to the health and our ecosystem as well. So as I mentioned before, it starts from 0 and goes up to 500. The higher the AQ value, the greater the level of air pollution and greater the health concerns are. So by looking at this, these purple, dark purple and purple colors, or even the red color or the orange color, that means your health is actually at stake. So you should avoid those areas where we have air quality index for in those colors particularly. And for instance, an AQI value of 100 generally corresponds to national air quality standards for the pollutant, which is the level EPA has set to protect public health. When AQI values are above 100, air quality is considered to be unhealthy. At first, for certain sensitive group of peoples, like elderly people, children's, for sick people, people with certain ailments like cardiovascular ailments. Then for everyone, as AQI values get higher than 100, then they are unhealthy for even the general public or for the masses. Okay, if the EPA established an AQI for 5 major air pollutants regulated by Clean Air Act, each of these pollutant has national air quality standards and EQs set by EPA to protect public health. So if I ask you guys, which are actually these criteria pollutants? Can somebody tell me in the text, or or tell me by unmuting its mic, which are actually these criteria pollutants?
Can I contribute?
Sure, sure.
This is the carbon monoxide, the nitrogen oxide, SO2, particulate matter.
Yeah.
They actually, right? And I think
the fifth one.
Lead.
Lead is a part of particulate matter, but yes,
okay.
lead is also. Yes, the sixth one important is missing.
And
one.
ozone.
Yeah, tropospheric ozone. Excellent, excellent. Full marks. So here I have my own list as well. So you see the ground level ozone, which we also call bad ozone, and also the tropospheric ozone. It is not only air pollutant or criteria pollutant, but it also a climate pollutant or greenhouse gas as well. So it also impacts the climate as well. Then with particulate matter, we have PM10 and PM2.5, and even the ultrafine particles, PM1 is taken into consideration nowadays by the certain Western and even in China as well. The lead is actually, we can identify only on the basis of when we have chemical composition analysis of these particulate matter, then we can identify lead. But in principle, when PM10 and PM2.5 is within the limits, then the lead is actually compromised. It can be compromised or accommodated. So the next one is carbon monoxide, and then sulfur dioxide, and then nitrogen oxides. So all they actually constitute the air quality, and these are the air quality categories. So the first band actually goes for 0 to 50, and that is actually the good air quality conditions. The second one is starting from 51 going up to 100, and this is moderate level of pollution. It might be not good for some infants or something, but it's livable. But when the air quality value goes beyond 100, then it becomes sensitive for becomes unhealthy, particularly for sensitive group till 150, and then 151 to 200 for unhealthy for all group of people, and then very unhealthy for all group of people for 201 to 300, and then 301 to 500 is hazardous. So the warnings are issued when the air quality index goes beyond the 300. That restrict your outdoor activities, limit and try to avoid exposure to air quality index. So my question is, can one air quality index could be representative of a whole city, a city like Lahore or Karachi? Quickly, somebody from the audience. Anybody from the audience, please? Can AQI value, for instance, a place in city of Karachi, city of Karachi has AQI of 500. Can we take it as 500 for whole Karachi?
No, so the answer would be no, because that's a single reading for a particular location, and the concentration of the pollutants, they can be different in different parts of the city, depending on a number of different factors, which include the sources of emissions as well as the environmental factors as well.
Yes, the answer is yes and no, both actually. Yes, in the sense when we have several constraints that we have limited measurement facilities and capacity that we cannot actually go for the final spatial resolution, then answer is yes. Yes, and normally the answer is no, because it's not necessarily that always each part of this our segment of the city is having the same hazardous level of AQI. So this is very much confined to, it's a very localized index, by the way. But keeping in view the constraints of monitoring infrastructure, then we can go for that. Obviously, the meteorological parameters have to play a role. So they might, for instance, if the place A has a AQI of 500, then it might be impacting downwind to up to 200 level as well, or even 300 level as well. So the answer is both yes and no. It depends on the circumstances. Okay, so this is why we should be concerned about all these colors. So if you see here, air quality index level, good, and then the numerical value and what are actually meant for that particular green color. When you see the air quality is considered satisfactory and air pollution poses little or no risk. So that means you can go for your routine life without any consideration. Moderate level, again, this is the same, safe levels, air quality is acceptable. However, for some pollutants, there may be a moderate health concern for a very small number of people who are unusually sensitive to air pollution, like allergies or something like this. Okay, and the third one is unhealthy for the sensitive group. And here the concern actually goes on. Members of sensitive group may experience health effects. The general public is not likely to be affected. Unhealthy, which is starting from 151 to 200. So everyone may begin to experience health effects. Members of the sensitive group may experience more serious health effects. Very unhealthy, 201 to 300, and the health alerts, everyone may experience more serious health effects. Hazardous level, 300, beyond 300. Health warnings of emergency conditions, the entire population is more likely to be affected. So you see, this has made the job very easier, the life very easier. Just recognizing and the colors, you don't need to go for whether what is the NEQ value, what is the NEQ standard, and what is the current NEQ. So this has made life simpler to gauge whether the air pollution levels in that particular part of the city or particular city or country is at what level actually. So if it's a green, it's no issue, or yellow, it's also safe. Unhealthy for sensitive group till orange is acceptable, but certain people, group of people should avoid those areas. But red and then violet and the dark violet colors, this is going to be disastrous or hazardous for masses of people. Okay, so how it is computed actually? This is a generic, very standard formula for air quality index calculation. Air quality index, we have I high and I low, and then similarly C high, the current concentration of these pollutant and minus C low. So obviously you need to monitor the actual concentration levels of the pollutants. So C is the pollutant concentration level, which you have measured for certain time period. Some pollutants requires for 1 hour average, some requires for 8 hours average, some requires for 24-hour average. And then C low, the concentration breakpoints, and C high is concentration, upper concentration breakpoint, which are already established by the EPAs. And I low is the index breakpoint, so the numeric value, and similarly I high is the highest index breakpoint. So this is the table that will give you an idea what actually the C low and C high, these are actually the criteria pollutants, and then AQI, these are the breakpoints for this AQI, I low and I high. So, and you see the relevant the air quality tags or colors are actually there. For instance, it's for ozone. This is again for ozone. This is for 8-hour average. This is for 1 hour average. PM 2.5, PM 10, CO, SO2, NO2, and then AQI breakpoints. And then these are actually the categories. Then how we calculate this? For instance, I give you an example. If the current concentration of PM 2.5 is 31 micrograms per meter cube, as per Pakistan's NEQ's level, this is well within the limit, which is 35 micrograms per cubic meter. But if you calculate the AQI value, that will fall in. For instance, here, 31, that will go here. And the lowest concentration for this is 12.1. and then the upper index value is breakpoint is 100 minus 51, the lowest one, and then you have to compute according to the formula. This is repeated again. So our outcome is actually the 91, and if you look at the category, that 91 falls in the moderate category. So that means our air quality index was in the moderate level, so the air quality conditions were good. It was acceptable. It wasn't hazardous or toxic. Similarly, we have several modes of AQA indices. Now, different countries have opted different levels. Some have started go to 1 to 10 or even higher, but they have given some different names. But all the methods are actually based on these NEQ values in the same procedure that I have explained you in the previous slides. For instance, Hong Kong has replaced the air pollution index. By the way, air pollution index is also again the same term that has been used in past for AQI, and with the new index called the air quality health index. And in the Europe, the common air quality index is an air quality index used in Europe. This is CAQI, is a number on scale from 1 to 100. But again, the weightage is with respect to these color coding scheme with respect to the impact, health, their impact on health, human health and the environment. In our surrounding areas, India has also AQI categories starting from good, satisfactory, moderately, poor, very poor, severe. And the China also has excellent, good, light polluted, moderately polluted, heavily polluted. So you see, all the countries have different AQI levels and cannot be generically have. And what's about the Pakistan? Pakistan have very, I would say, a bit lenient than the rest of the countries where we have seen. Here would see the minimal impact at the good air quality conditions goes up till 0 to 100. And 101 to 200, this goes light green, which is satisfactory. But if you compare with the other country, 101 to 200 is moderately polluted in India, and it's moderately polluted in China as well. But if you look into, for instance, USA, it is unhealthy for all public groups. So, and similarly, if you see the Pakistan scale goes even beyond 500, and they have started hazardous level beyond 500 level. In principle, that should start from 300 levels. Okay, so this is again the China and India. So yeah, one important message for you guys. So for instance, if I ask you, how do you pick up, because air quality index is constituted by the 5 parameters what we have seen before. So if I give you an example, so AQI for SO2 was like 100, and AQI for tropospheric ozone was 200. So, and similarly, AQI PM 2.5 was 150. So what will be the air quality index of that particular location at that time? Any answer? The volunteers, please. Any answer for this? Yes, Iftikhar, yes, you're right. It is always the highest AQI value, irrespective of the nature and the type of the pollutant. So always the highest number will be representative of the AQI of that particular place. So I have given an example. So I quit here and I'm ready to take your question, please. Thank you very much for your attention. So any question, please?
I have a question, Dr. Fahim, please.
Yes, please go ahead.
Actually, the air quality index, which we are looking at right now, for example, it's based off of USA, and a few of their stations are also located in Pakistan. But I was wondering, they are not located all over Pakistan. How reliable are those? For example, if I use the same air quality index for Abbottabad, where I am right now, and it's giving me the AQI of Islamabad. So can I use that for Abbottabad, or maybe can you give me a number, for example, by kilometers, or some criteria based of which we can use this air quality index, for example, for the neighboring cities or regions? Thank you.
Well, it's a good point. We have already discussed this. So the first thing is that we cannot actually use this AQI number from Islamabad to represent the AQI at Abbottabad. This is for sure. And the second thing is that obviously, even if the dimension of city is quite large, one single point monitoring is not sufficient enough for that, particularly because the city infrastructure and topography and the building, skyscraper buildings, they impact a lot, and also the ventilation. And if that particular point where the AQI or where the air quality monitoring station is there, if it's vicinity of some industrial area, then definitely it's not going to representative of the city or to the peri-urban area. So it's a very tricky business, but normally, again, I would say for sure, it's not representative AQI of Islamabad for the Abbottabad. But if there is any AQI that is based on any measurement in Abbottabad, yes, to a certain extent, you can accept that one. I hope I answered the question.
Oh, yeah, thank you. Got it.
So there is another technique that we scientists actually use, just to add on, if there is no other question, I just want to elaborate more. So we use the air quality modeling techniques, and this is how we actually use the different, especially scarce data we interpolate between these stations, keeping in view, because the modeling is to understand the mechanism and processes, what's going on about the air pollution mechanism and dilution factor and all these things. So these modeling results can be used. It could be another best available alternate for that particular places where we don't have actually the air quality monitoring, ground-based monitoring station. And the second best alternate is the satellite observation that gives you a comprehensive, a complete picture over a larger area. You can go for qualitative, not the quantitative. Satellite can give you just qualitative assessment. Quantitative assessment with the help of satellite is not possible, and it's a totally different scenario.
Yeah, thank you, Dr. Fahim. Actually, this was one of my points yesterday when we were having a discussion with Dr. Khokhar, that if there is any model, I could not find, first of all, I could not find any study based off of Pakistan, which used the model data and compared it with the help of satellite data, so that we could have corroborated the sensitivity of that model, or actually the reliability of that model. I'm not sure if I could find that, but could you please help me with that? Or is there any study going on or already been done in this regard?
Well, this is a very good point. So unfortunately, Pakistan still lacks in this field of air pollution forecast modeling, air pollution modeling particularly. There are very few people, and I hardly know one or two, that has a little bit of expertise, but they have done work when they were doing a PhD in abroad, but they could not replicate somewhere into full scale in Pakistan. Yes, Pakistan Meteorological Department has meteorological forecast, but not the pollutant forecast as well. It's a very new area of chemical weather. We call it chemical weather forecast. Still, it's recently employed in Europe as well. So when I was doing my postdoc back in 2008, I started my postdoc in France at University of Pierre Marie Curie. So at that time, it was consortium of 48 European research institute. That the idea was to develop integrated forecast system for not just for the meteorology, but also for the chemical weather forecast as well. And that was successfully implemented. And you can look for that from ECMWF website. But again, this is very much relevant to the European, where we have much ground level observations and validated emission inventories, but it can again could give you a rough estimate about countries like Pakistan. So they are doing at a bigger scale, but again, when you go for the bigger scale, the computational cost and accuracy matters a lot.
Yeah, I agree. Because we would need a lot of correction factors, and there are a lot of rough patches. So modeling may be reliable, may not be reliable, but we need to do it by ourselves over here.
Yeah, models are actually, look, there is a significant difference. What you measure at that instant, this is like the endpoint. So how that truth has evolved over the time to reach that particular point when you measure it, this is explained by the modeling. This is kind of theoretical explanation of the science. The models are actually developed, and they are always in the evolutionary phase. Improvement is always there. But recently, with the validation, with the models are quite validated within the modeling community. Against the models, they use different scenarios. There are ensembles, forecast always there. They experiment how good is and robustness of their models towards anything. They validate their model against satellite and ground-based observations as well. You know, we cannot rule out that only when you have a good model that can be actually sufficient enough to go for this. Still, you need to update your emission inventory model against the ground-based and satellite observations, always.
Okay. Thank you. Thank you, Dr. Fahim.
Okay. Any other question from any other audience, please? If no, then I stop sharing and I'll see if there was any question in the chat as well.
Are the same useful?
Ali, I'm done.
Yes.
Any questions?
All right, sir. Thank you, Dr. Fahim. We will take this time for a break now. So we will take a 10 minutes break. Although we are running behind the schedule, but sir, break are important.
One thing, there is a one point from Hassan Bukhari. I think, hey, if you allow me, then I can elaborate on this.
Gigi, please do that.
I think models are more useful to gauge impacts for specific sources like power plants, but very hard to model the ambient air quality as there are so many sources, cars, fugitive emissions. Yes, Ali, but it's what we were talking about. There was primarily about air quality models, which take into account the ambient air quality conditions. They are quite good enough, so their accuracy is more than 80%, which is quite good for that. And what you are talking about, this is particularly the dispersion modeling. This is for kind of to get NOC from environmental agency if you are going to check the efficacy of the new industrial unit or existing industrial units. So this is AeroMode is one of the best example from US EPA about air dispersion models. So this is mainly for the static sources and how they are going to impact the downwind in the surrounding areas. And then there are two questions from Mohammad Hassan Dajana from Dr. Fahim. Why does the Pakistan and the US EPA have different? And why does the Pakistan and US EPA have different EQ indices? Number one. I'm not right person to answer this question because I wasn't involved in when the AQI was it was established for Pakistan. I guess just to avoid the public cry or public reaction, they have lenient scale, but it really didn't make any difference that the Pakistanis have more immune to the certain pollutants than the Americans are not. This is not the case actually.
Uh,
So
can I go ahead and ask the second question, Dr. Fahim?
yes, please.
Dr. Fahim, we learned yesterday, and the US Embassy consulate in Karachi, Islamabad, and Peshawar has 3 monitors, right? When it comes to Pakistan, the EPA session that we had earlier, we had presentation of slides, but I couldn't access the data of EPA from Pakistani cities. So are we lacking in the data sector or the real-time monitoring, or are our sensors not as good as the Americans? The data aspect I'm asking.
This is actually the lacking of the monitoring facilities. US EPA, Pak EPA in H8 has a certain facility, but that is active since 2018. But the rest of EPDs, they don't have actually active monitoring going on. So occasionally they have some monitoring capacity. But when we talk about the quality of monitors, yes, we do have similar, because the US Pak EP is also following the same standard method, which are recognized or well established worldwide. They're using the same techniques, same instruments. So, but there is, I guess there's several financial constraints, but I guess Dr. Mohsina, if she is around, she can answer better. She is in better position to answer this question. Dr. Mohsina, if you are around, can you please elaborate?
She is not, I think, although she's logging, but probably she's not around.
Yeah.
So, in the interest of time, Dr. Fahim, Acha, I'm here. Dr.
Yes, please. Yes, can you repeat the question?
So the question was why we have different AQI standards and categories in comparison EPA, Pakistan and US EPA. And the second thing is that why we're not having an active or continuous monitoring in different cities of Pakistan.
Actually, as far as second question, we have active system in Islamabad. We are monitoring 24/7 air quality. As far as AQI concerned, actually US and Pakistan have totally different situation. You know, fuel quality, industrial setups and other things, road setups. So we cannot have, I think, AQI will be the same. But if we develop AQI system for Pakistan, we should consider our health department and fuel quality and industrial and vehicle policy, all things we should be first be consider, then we can, I think, develop AQI.
Thank you, Dr. Mohsina.
Yes, can I just quickly add on to that? It's a very important point that has been discussed so far, just for a couple of minutes. In terms of the air quality monitoring for particulate matter that is currently undergoing in Pakistan, there are 4 stations. So one is in Islamabad, one is in Peshawar, the third one is in Lahore, and the fourth one is in Karachi, and these are in the consulate generals. So they're not 3, but they're 4 in fact, and they're monitoring PM 2.5. When it comes to the monitoring by the Environmental Protection Agency, the provincial ones, then these monitoring stations, they were initially established under the JICA funding. It was a huge project which was implemented in Pakistan through a huge budget. And the Japanese came, they built the capacities, they did the installations, and they helped Pakistan to start monitoring air quality in the provincial capitals as well as in the ICT. So once that funding was over and the Japanese, they went back, these monitoring stations, they were just non-functional for so many years. Even till date, in the provinces, they're not functional. So even though they have been installed in the Environmental Protection Agency's buildings, but they have been non-functional. And this brings me to the point that we need sustained funding for air quality monitoring. And this needs to be part of the ADPs or the provincial budget allocation, which is very important. So we need to actually focus on measuring the air pollutants in all the provinces, in all the major cities. And in that way, we'll have a better picture of the air pollution in Pakistan. Thank you very much.
Thank you, Dr. Asif, for sharing your input as well. Ladies and gentlemen, with this, we conclude this session 1. I'm stopping the recording.